unit, we're going to be talking about systems of equations. Now, if you remember when we talked about with our PBL, where we had a cost equation, and then we had an income equation, and hopefully your income was greater than your cost. And we're going to figure out later on in this unit where you would break even and how many items you would have to sell to break even. And then after that, anything you sell is pure profit. And then we'll figure out a certain number of items you need to sell to reach a certain profit given your product or your project. But the whole point is a system is two or more equations that you're using to compare different information and find where they have a common solution, like the break-even point. So what is a system of equations? It's two or more equations. That's it. Simple as that. And basically, what is the solution to a system of equation? It's the common solutions. And common solutions, we're talking about ordered pairs. Oops. X comma y if possible. Because we'll see, like for example, parallel lines, do they have any points in common? No. They'll never intersect like our income and cost equations did for our PBLs. So in fact, if you have parallel lines, which remember we said that these had the same slope or same m's, there's going to be no solution. The reason why there's no solution is because they have no common points. Normally, I'd say about 90% of the problems you're going to get where the two lines intersect at one point. And so we say the solution is one point, which we always state as an x comma y ordered pair. And again, it's created because the lines intersect at one point. Now, when we say identical lines, basically it's the two lines are exactly the same equation. They have the same slope and the same y-intercept, so they're basically the same equation. So when you solve for y, when you get your y equals mx plus b, they're going to be the exact same equations. And guess what? There's infinite solutions. Oh, I can't spell today. What's new? Okay. And just as a review, for no solution, we use the symbol empty set, and for infinite solutions, we use the symbol infinity to show that there's an infinite number of ordered pairs. So every single point on that same line is a solution. And then over here, we just use the single point, the x comma y, as the solution. Now today, we're going to solve by graphing. Okay, that's back to what we did in Unit 4 when we graphed them, but we had to make sure that it's in y equals mx plus b, so we can read our b is the y-intercept, where it crosses the y-axis, and your m is your rise over run for your slope. Okay. So first of all, I would notice number one, both equations are in y equals mx plus b, so we're good to go. So is number 2. But if you look at the back side, number 3, both are in standard form, so we have to solve for y. Then we can graph. Number 4, only the top equation we have to solve for y, but the other one we don't. And you can notice kind of throughout, there's some that we have to solve for y and some that we don't. We also have some special cases. Remember the HOI where we talked about the horizontal line? When there's only a y in the equation and no x, so that's horizontal. We also have the VUX where there's only the x and no y. Okay, so we're still going to be using those special cases throughout. Okay, so let's go back. I'm going to do the odds with you. So first of all, first equation, our b is -8, and the m is +1, but we're going to write it as 1 over 1. And if you remember, two positives divide the same as two negatives, and that gives you a positive slope. Okay, so if we go down to -8, here's our y-intercept. Then we can either go up 1, right 1 for the positive 1/1, or we can go down 1, left 1. Now the thing is, our goal is to see if these two, well, let me tell you something else I noticed. Their slopes are completely different, so there's for sure no solution. And since their m and their b are different, there's for sure not going to be infinite solution. They're not the same equation. So we know there's going to be just one point. So it's going to be an x comma y somewhere that they intersect. So because I know that, guess what I'm going to do? See these points that I used for the first line? I'm going to extend using the slope all the way across the graph. So then now I have all the points across the graph. So then when I graph the second equation, it'll be faster to find the solution where they intersect, or the point where they intersect. So the second equation, we know the b is +1 and the m is -2, but all whole numbers we can write as over 1, and a negative over a positive we can write as a positive over a negative. We just have to make sure we only go negative in one direction. So our y-intercept is +1, then we can go down 2 over 1, and guess what? I wouldn't even use this one, because guess what? I'm going towards this line that I know they're going to intersect, since the m's are different and they're not the same equation. So these two are out. It has to be this one. So I'm going to keep using only this slope, because I don't want to waste my time going away. I want to go closer to this line. So I'm going to go down 2 over 1, down 2 over 1, and boom. It's kind of like Battleship. I hit that line at this point. So my answer is the x comma y for this point. Remember, x comma y is opposite slope. Remember slope, we do y's, the up and the down first, and then the x's, which are the left and right. Well, guess what? Our x comma y, we do the x first, which is left and right, and then the y. So the x is +3 and the y is 1, 2, 3, 4, 5, -5. So our final answer is +3, -5, and boom, you're done. And you have to make sure you have the parentheses for the ordered pairs, or it's just a list of numbers rather than a location on the graph. All right, so let's look at number 3. So both of these I need to solve for y. Fortunately, I can tell that the y's already are a 1y, so I actually don't need to divide by anything, so it's going to take me one step to solve for y equals mx plus b. So the top equation, I'm going to add 3x to both sides. So our first equation is going to be y equals 3x plus 8, since the 8 is positive. So the b is 8, and the m is 3 over 1, which I can also do 2 positives divide to a positive, just like 2 negatives. Okay, so if I graph this first line, I go up to my b is 8. And now I can go up 3 and over 1, but it goes off the graph. So I'm just going to use my common sense and say, okay, I'm going to use the 2 negatives and go down 3, left 1. So I have 2 negatives, and I'm going to keep going all the way across, use all the grid across this graph so I can find all possible points. So when I graph the second equation, it'll be fast to find the solution. And then the second equation, all I have to do is get rid of the negative x, so I add x to both sides. So I get y equals +x minus 2. So our b is -2, and the slope is 1, since the coefficient of x is 1, and we just write that as a fraction, 1 over 1. And we might need since 2 positives divide to a positive, just like 2 negatives, we'll see which one we need, okay? So let's start with the y-intercept, which is -2. And if I go up 1, right 1, I'm going away from the line. But if I use this again, I'm going down 1, left 1, and if I keep going down 1, left 1, all the way across, boom, I hit the first line right there. So I know this is my solution. Now I just have to count the x comma y. And remember, x comes first this time, which is the opposite order of slope. So the x is, let's see, 1, 2, 3, 4, 5. Actually, it's -5 because it's to the left of the origin. And the y is 1, 2, 3, 4, 5, 6, 7. -7 since it's below the origin. So our final answer is -5, -7. Now, I'm actually going to draw the special case first because that's a piece of cake. We know it's a HOI, or horizontal line, that crosses at -7. So I'm just going to draw that horizontal line, and I know wherever this first line crosses this horizontal line is going to be my answer. And you know a shortcut is that the x comma y point, well, since the y's on this horizontal line are always -7, guess what? The y is always going to be -7 for the solution. We just need to figure out what x value it crosses. Well, in order to do that, the first equation, I'm going to subtract the x term. So if I take the x plus 3y equals -15 and I subtract the x on both sides, so 3y equals, I can't combine these, so I have -x minus 15. Then I divide by 3. So then y equals -1/3 x, and -15 divided by 3 is -5. So my b is -5, and my slope is -1/3, or that's equivalent to 1/3. So we go down to -5, and then our slope down 1/3, and I'm going to keep going down 1/3 because I'm going towards the line. And guess what? I found the point. We know the y is -7, but all we have to do is figure out what the x is. Well, the x is 1, 2, 3, 4, 5, 6, and the y is -7. We already knew that. So it's +6, -7 for the final answer. Okay. Now look at number 7. We're going to have to solve both equations for y. So the first equation, 3x minus 5y equals -35. We're going to subtract 3x. So -5y equals -3x minus 35. Divide by -5. So then y equals +3/5, since a negative divided by negative reduces to +3/5 x. And -35 divided by -5 is +7. So my b is 7, and my slope is 3/5, which is also equivalent to the two negatives. And we'll see, we'll probably end up using both. So if I graph this line, I get a y-intercept of +7. If I go up 3 over 5, I can only use that once. So then I can go down 3, left 5, and then down 3, left 5 again, in case it's at, and then just draw that first line. So hopefully at one of these 4 points, the second equation will cross. But now, all I have to do is subtract, on the second equation, is subtract the 2x. So if I have my 2x plus y equals -6, subtract the 2x, and then you get y equals -2x minus 6. I don't have to divide anything. My b value is -6, and my slope is -2, but we write it as -2/1, and that's equivalent to +2 over -1, since a negative divided by a positive is negative, just like a positive divided by a negative. So let's start at our y-intercept is -6. Then if I go down to right one, it takes me further away from the other line. I know I want to get to this line, so I'm going to use the equivalent slope of going up to left 1, up to left, up to left 1, up to left 1, up to left 1, boom. There it is, okay? So this is my solution. Well, the x coordinate is 1, 2, 3, 4, 5, and since it's to the left of the origin, so it's -5, and the y is 1, 2, 3, 4, so it's +4 because it's above the origin, and there's our So on number 2, both are already ready to graph in slope-intercept form. So the first equation has the y-intercept of +9 and a +1/2 slope, so I go up 1 over 2, but I'm running out of room, and I know a slope of 1/2 with 2 positives divide the same as 2 negatives. So I can go down 1 and left 2 and keep going down 1, left 2, down 1, left 2, all the way across, and then draw a line. The second equation crosses at +6, and it has a slope of -1, which we can write as 1 over 1. So if I go down 1, left 1, gosh, that was 2 negative directions, my mistake. Down 1, right 1, I'm going away from the graph, so I want to do a +1 over a -1, because a positive over a negative is equivalent to a negative divided by a positive, okay? Both give you a negative slope. So we're going to go up 1, left 1, up 1, left 1, and boom, it hits at this point. And the coordinates of this point is -2, +8, like the answer shows. Now for number 4, all we have to do is solve for y. So the first thing I'm going to do is subtract the x term. And then basically this rewrites as 2y equals -x plus 4, because the 4 is positive. Now I divide everything by 2, so I get y equals -1/2 x plus 2, and guess what? These are exactly the same equation. Remember we said over here, if they're the same equations, it has infinite solutions, and basically I could graph these the same. The y-intercept is +2, and our slope is -1, so go down 1, right 2, or up 1, left 2 for a negative slope. And guess what? They have infinite points. Every single point on that line that goes on forever in both directions the same. So that's why the answer is infinite. Now, if you look at number 6, the only one we have to solve for y is the second equation. Now I know the answer is no solution. Well, no solution, what has to happen? They're parallel lines, which means they have the same m. But they're not the same equation, so they have different b's, okay? So if you look at number 6, all we're going to do is go ahead and subtract the x term on both sides. Don't lose the negative on the y. So I rewrite this as -y equals -x plus 2. Now I'm going to divide by -1 since the coefficient of y is -1. So you get y equals, and this is a +1x minus 2. Now notice, both m's are the same. Both m's are 1. So guess what? They're parallel lines. Well, if they're parallel lines, the first equation, I still have to graph it, crosses at +5, has a slope of 1 over 1, so I go up 1 over 1 and keep going, or down 1, left 1, so I can connect this. Second equation has a y-intercept of +2 and the same slope, +1, so it's up 1 over 1, or down 1, back 1. And guess what? There's the parallel lines, but you still have to graph it. See what the directions say? It says solve by graphing. That means you must, even if you already see that the m's are the same and the y-intercepts are different, you still have to graph the two lines. But the answer is no solution because they have no points in common. They never intersect. Now the last, number 8, we have a vux. So the x at -2 is a vertical line. And I love the special cases because they're so simple. And guess what? Since x is -2 on this line, that's where the -2 on the x, we already know that just from the vertical line. We just have to find the y, by solving for y on the second equation and graphing it and see where it crosses this vertical line. So first thing I'm going to do is subtract the 3x on both sides. Don't lose track of your negative. So I have -2y equals -3x minus 18. I'm going to divide by -2. So then all the signs change and you get y equals positive 3 over 2x plus 9. So I go up to positive 9. If I go up 3 over 2, I'm off. But remember, a slope of positive 3 over 2 is equivalent to negative 3 over negative 2. So I can go down 3, left 2, and boom, I hit right away first time. And the x we know is negative 2 and the y is 6. That's where we get this point. That's where they intersect. So bring questions to class.